I am going to be using some of this time today on my weekend to catch up with a week's worth of HTM Forum conversations. And first I will go to the forum and tell them that's what I'm doing. So I have only recently started doing Twitch stuff, and then I took a week off. And I was totally like offline for a week at my kids' science camp. Okay, I am live streaming now while I'm catching up on HTM Forum conversations. Join if you feel like chatting. I think maybe I should put my URL in there too again, just in case somebody forgets. Well, no. I don't want it to be a giant link every time, so I'll just put it in here. Okay. So now, if anybody happens to be online, because there's usually people online. So now I'm going to look and see on all the unread topics that I have. Let's see if this works. I'm still figuring out all the Twitch stuff. So like so this is the broadcaster setup. So I should see like that chat. Yeah, you see the chat pop up, but it's all white, so you can't really actually see it. So I should probably fix that, but I don't really know. I'm still figuring it out. So it doesn't show up on the white background very well, but that's okay. Back to the forum stuff. So I think those are like Twitch telling me that I'm live streaming, obviously. Okay. So I'm going to go through the forum and start answering questions because I missed all these topics. So there's a lot of nice, interesting conversation, probably. We'll find out. So how much trust swarm results? This is Sam. So we've been going back and forth on this. It started with a question about the adaptive scalar encoder because the swarm was returning an adaptive scalar encoder, and it really shouldn't be because we don't even use the adaptive scalar encoder anymore. And he was asking if he should trust it, and I told him no. But now we're dealing with some other issues. I don't even know what's going on here. Everything's seems to be plotted in different resolutions, and I'm totally confused about what's going on. And I asked for Subutai to answer this, but I know he's been super busy. He was gone at Cosine for like a week or more, and he just got back and is swamped with stuff. He's got a paper he's working on, and I know this is not a high priority for him. I don't even know if he saw this message, honestly. But I don't know the answer to this yet. Why is the bucket index? Maybe there's a function somewhere. Might a function like this work to convert? So, yeah, I mean that function might work, but it's definitely not the right thing to do. I don't know what to say about this. This is a tough one. So there's some bug in Sam's setup, and I can't figure out what it is. I don't understand why when he sends in a new row of data, he gets back a prediction that is referencing the encoder's bucket index as the value, the most likely value, and not the actual encoded or decoded value of that. So that's the problem. But I don't know why. I will have to dig into this because I really don't know I'm not even going to answer it because I don't know the answer to this question. So I'm just going to leave it. I hate leaving things like this, but I just don't know the answer to the question. Okay, installing NuPic on a Raspberry Pi. Oh, these topics. People have been installing NuPic on a Raspberry Pi since like 2015. I think was the first time I saw somebody do it, which was pretty impressive because it's really hard to get all of the C++ binaries compiled properly on an ARM because you have to bring in so many external libraries onto it yourself. And this is totally not my forte. Looks like Paul's definitely got a lot of experience on this aspect of NuPic. By the way, NuPic is the Numenta platform for intelligent computing. It's the Python / C++. There's a C++ part of it for speed implementation of hierarchical temporal memory. So there's a lot of traffic on this forum about NuPic, like technical things. It's software. I was able to start HTM service with basic functionality without errors on a Raspberry Pi 3B+. Cool. In total, I spent not much more than 2 hours. I also found 2 mistakes. Okay, cool. So I think he's pointing out some things in Paul's tutorial, and Paul already liked this. I like it too. Good job. I'm going to call him a community helper. If you find some bad documentation or something and you point it out, that's good juju. That's a community helper. Okay, thank you, George. I don't think I need to respond to that. I'm bouncing back here because I can't tell how many users are watching. So there's 3 people watching. That's nice. Anybody, if you have a question about anything, feel free to jump on chat. I will take questions. Path anomaly detection using grid cells and temporal memory. This is Marty. Marty's project. Marty is doing some really cool stuff. I still need to figure out how to get this running. So he's implemented this grid cell-like encoder, or so let's see what it's. Oh, he made a video. I haven't seen this yet. Is this gonna work?
Hello, yeah, this is a demonstration of my final project in my AI course in my university.
Oh, that's cool. Okay, so I need to get this running because that looks cool. So he's doing some type of grid cell module type encoding. It looks like you can see the actual encoding on the top here where it says grid cells, and then this is the prediction of where it's going to be next. So he's running temporal memory, and then he's got an anomaly score here. Something's right. This doesn't seem. It should be doing better.
What the algorithm has to learn, and on the bottom is what the algorithm hasn't learned. And under that is the anomaly score history and the score itself. The history shows the history, and the score is how horrible is the algorithm.
Okay, so it's got the whole history like a window, and then the
weird the path is now.
I don't see a likelihood though.
How we evaluate the algorithm on detecting.
Yeah, so this should be a very low anomaly likelihood at this point because it's just going in a circle. So hopefully you'll move it now. We've changed the path.
The algorithm has just started learning, so you see the anomaly.
So I'm guessing what Marty's going to do is. Hey, wait, let me make sure that this is actually working. Yeah, it's working. I don't know if you guys can see this. Can you guys see what I'm showing? Because I put this video in like full screen. Let me make sure that you guys can see it. So I'll do it in theater mode. That way I know you can see it. Hey, Derek. Am I saying that right? Derek. Oh, you can see it in full screen. Okay, you can probably see. Oh, good. Something happened. Hold on. All right, so I'm guessing. See that anomaly indication there, like the history. See, he just moved, and the anomaly went boom. So the algorithm was learning this path in space, 2D space, and then when he moved it over, the anomaly was like bumped back up. And then when he moved it back, the anomaly goes down. Cool. And did you see those like those little things like that? That's probably because it crosses every time it crosses a path that it's been before. It's like, well, that's not anomalous because I know what that is. So he moves it completely into a different place. It's really high anomaly. This is awesome, Marty. I like this. So for those of you, if you're watching and not in the community, so the community members are going to know what I'm looking at, sort of. But for you Twitchers, is that a good term? I hope. For you people on Twitch, one of the things we can do with one thing we know about grid cells. If you can look up grid cells. There's an HTM School episode about it. Just search for grid cells on YouTube. The first video that comes up is me. I'm very proud of that. Anyway, grid cells are really cool things that can help you map out space. It's how sort of a way that neurons in your brain map space or learn space through movement. And once you're an adult, you've already got these complete maps of space. Like, you know how space works because your grid cells are working, and they have been working for years and years. And what Marty's doing here is he's encoding space in a two-dimensional space using sort of a similar mechanism, using things called grid cell modules. And we can use properties of those to learn the movement of a thing over time, an object through space. And temporal memory, the part of HTM, hierarchical temporal memory, like the temporal memory part of that algorithm, can remember that location in space over time based on how the grid cell modules update as the thing moves through space. So what he's doing is he's like sort of training a system. It's not really training, it's just the system is observing an object moving through time, and it gets used to it. After a while, because it's always predicting. Engines your brain is always predicting. Everything it's observing, it's always predicting what it's going to do next. So again, like the HTM algorithm is again always creating predictions about what it thinks is going to happen next, or what sensory input it's going to see next. In this case, when he moves the track, the object's moving to a different place, then its predictions all become wrong. Because it hasn't seen the object move over here yet, so it takes a long time for it to see it. Okay, I see it over here now, because that builds up over time. New synapses that links locations in space. Like, as it sees it over and over and over, it's like dialing it in. There's new synapse growth every time it observes something, and after a while, it'll have learned like many different patterns, however many it might have observed, and you can sort of bounce between them. And that's one of the things that Marty's showing here, is jumping back and forth. I'm still sort of want to see what's going up here.
And it's sorted 5 pixels, and again, immediately the algorithm finds the anomaly and generates a score indicating that
HTM is a continuous online learning system, so every new location, all he's sending in is a location of this circle at this point in time, and then the next step it moves a little bit and he sends in that new location, and that location is encoded into a sparse representation using this grid cell mechanism. So grid cells have sparse activations, just like all the neurons, the pyramidal neurons in your brain have sparse activations, meaning only a small percentage of them are actually active at any time. And so this location is basically converted into a sparse representation of space, and that's what the memory algorithm is learning over time, like this sparse representation of that space and what comes next and what came before it. And because these cells are actually representing neurons or the synapses between the neurons. And so as long as you have learning turned on, which is like just a parameter that you can change as you're running the algorithm, it will continue to update all the synapse weights, permanence weights we call them, and continue to learn as something moves. As long as you have that, so you can turn learning on and off. But HTM is definitely a continuous learning system. It's very different from like Bayesian networks, deep learning networks, where you will have a huge space of spatial data, and you sort of process it all at once and extract properties of it. When you like facial recognition software, image classification, all the cool image stuff that's come out lately has all been these giant deep learning networks, convolutional neural networks that can find features in images and then call up all the different places it's seen those features sort of in different places and put things together based on that. But it's all using probabilities and spatial techniques, spatial classification techniques. What we're seeing here is temporal prediction, so through time, so an object moving in space, which is very different. It's a very different problem. This is the way your brain evolved to understand the world, through time, the exploration of space through time. So that's a big part of the HTM theory.
Anomaly, this algorithm could also learn
Anyway, I
multiple
should probably
paths
keep
without
listening.
forgetting the previous paths. So
if anybody's watching this, you can get to this on HTM Forum is at discourse.dementa.org, or you could just go to dementa.org, and there's a link to it.
For the sake of time, we'll be accelerating the process.
I love this. This is really cool, Marty.
And as you see, the anomaly scores
see, now it's going fast.
And pretty rapidly. And within a few seconds, it has dropped from 100% to
I want to go back.
Around rating the process.
Okay, check it out.
So, and as you see, the anomaly scores start to drop immediately and pretty rapidly. And within a few seconds, it has dropped from 100% to something around 20% and still lowering.
It's because it's learned this. So the anomaly goes down because it learns it. Just.
And as you see, the algorithm now recognizes this path as a normal path, and we can set the circle back to the original location. And again, the algorithm thinks that it's an ordinary path, but seems to think it's a bit weird. And that's okay. We could always force the algorithm to learn again.
So he's like speeding up time, I think.
The algorithm has relearned it, and it thinks that
it remembers sort of the last things that it saw. So
now we could switch.
It's similar to like memory in your brain. You don't have it's not like you have to dump memory in order to learn something new, but all the time when you're learning something new, I mean, the old memories fade into the background. Like you're not exercising those synapses anymore, so they become less strong. The more you practice something, the more you think about something, the more you observe something, the stronger the connections get between the synapses involved in that perception or in that sensory perception, and the more easily you can recall it. So it's not like you just dump old memory, but he's showing here is that he's got a circle and you can learn it, and then it can be predicting well enough that there's very low anomalies. But then when he moves it to a different place and he's learning over here and over here and over here, when he comes back to that place, it's not as settled. It's like it's more anomalous than it was when he had it there before, because you'd been observing a bunch of other stuff. So like some of those old synapses sort of will become overridden in a way because it's learned this other stuff. And there's actually settings in all these algorithms to decide how quickly synapses fade away, how quickly do we forget. And there's lots of ways you can go in and trim or prune different permanences or synapses to try and optimize, but that's a very big topic. Hey, no problem, Derek. Come back anytime. I'm going to stream on Monday, so hopefully I'll see you there. This is just sort of a test for me. Marty, that was really cool. I really need to get this working. Maybe I can, since it's in C++ and I'm awful at C++, maybe I can do this on Twitch. I can try and get your project running on another one of my work sessions on Twitch, and some of the C++ people that I've found there might be able to help me out. Twitch is amazing because I can help people with coding. Like I can go in and say, "Oh, I see what you're doing here," and people do that to me too, which is really cool. It's a great way to learn a new language. Yes. So I don't know what to say, Marty. I hope you're watching this because I think this is really cool. Video was awesome. I really need to get this project compiling and working on my iMac. Priority. Hopefully. This is a bad thing about Twitch because, like, my half-baked thoughts. If I do this while I'm actually updating the forums, I'm going to have a half-baked thoughts. I'm like, yeah, maybe I shouldn't say that, but then it's already live. I don't know. I was going to say next week, but I really don't know what this. I'll just say I'll make it a higher priority. I'll leave it at that. Okay. Okay, so can HTM predict previous inputs? I think we already answered this question. Paul stepped in and helped with this. Yeah, I think you can do this with sort of a backwards classifier, a back-looking classifier. Let's go link to the alternative sequence memory topic. Okay, create and run HTM in a programmatic manner. I think this is an old topic, isn't it? Okay, I like to fix errors. Programmatic manner. And I'm going to edit your question so I can fix a couple of spelling issues. Let's model, not from parameter configuration. File. I'll just leave. I shouldn't be going correcting other people's misspelling, should I? Thanks, Marty, for answering him. Thanks. Help. Example for making swarming. So this was while I was gone. Do you have any example for making swarming with the algorithm API? That's not really. So for anyone watching, swarming isn't very compatible with the algorithms API. You're going to have to build your own network API or algorithms. Swarming sort of gives you this canned file with model parameters, like a configuration file that works with the OPF. The OPF is the online prediction framework, and I'm trying to move away from it. I don't like the OPF. You have a lot more flexibility with the network API. If you do swarm and you find model parameters, you can certainly use those. Just look at them and then go through the API docs, like here on the NUPIC API. Quick start, like here we go. No, not OPF, algorithms API. So then you could go through, and if you look at this, I think maybe I'll just link you to this quick start, because this quick start's great because it shows you using the exact same model parameters file in YAML how to use those parameters to instantiate an OPF model, and then how to use those parameters to instantiate a model with the raw algorithms API, and then the same file, the same configuration file to do the network API. So I'm going to refer you to this. Okay, Mac. Mac. I think you will benefit from a review of the quick start. It is nice because it shows you how you can build out all three types of models: OPF, algorithms, and network API using the same model configuration, which is in a YAML file. Okay. NUPIC implementation and actor model. 7 days ago. How much of this did I miss? So I have not done any work with actors, with actor models. I know this guy D-Led. You were doing the Pony implementation. Or was it Erlang Elixir? I thought you were doing Pony. I'll find out. Erlang C node for Pony. HTM Pony, yeah. So he's got a Pony implementation, and apparently he's doing something with Elixir. But that's about an experiment on dumb neurons voting, which is each is modeled. So this is a big topic because with like Erlang, HTM should be parallelizable at some point. and the bottleneck there is really hardware, but in software, there's probably more efficient ways we could create HTM networks to where they could be distributed. And I think moving towards Elixir, Pony, or something is definitely a step in the right direction. Okay, so he's just asking if there's been any progress. And he's rebooted the Pony airline. Oh, I liked this before I left. Max Lee, I have a prototype of a scalar encoding spatial pooler. I've been able to work on this for a month. Landing down. And again, I've got it ready. Okay. This is going faster than I thought. Problem running the swarm in the hot gem example on Windows. Oh, first time user. Hello. Oh boy. So this error is because the file path is wrong. Someone's trying to run a swarm and they're trying to run it on a data file, and it's not where the program thinks it is. And I think that's as simple as that. He's having the same problem. He's getting iTunes error 9. Why would you get... So I'm unable to have access to the iTunes because the swarm on the Mac is not supported. Is this spam? There's like really weird, tricky spam nowadays. iTunes error 9? What? Both hardware and software. Wow, I've never ever heard of this error. Tommy Shelby. Have you ever, okay, seen 1 day ago, posted 3 days ago, joined 3 days ago, read less than 1 minute. I have a feeling, Tommy Shelby, I can't tell if you're a spammer. I can't tell if you're a spammer. Okay, I'm gonna err on the side of caution. I'm gonna assume you're a real person. Although I get this looks like a spammer's message, because usually it's like a very short message, and there's one link to it to a suspect page, and this page looks very suspect. So I don't know. So I'm going to treat you like a new member. Hi, welcome to HTM Forum. Thanks for your question. Okay, some days capitalization matters, some days it doesn't. That error, I'll just say, I have never seen that error before. Can you tell me the exact command you ran that caused the error? Alright, if you're a real person, hopefully you'll be able to answer that question. Ideas for HTM on FPGAs. This is an older thread. Oh no, it's not too old. Alright, so Marty, this is the guy who had the YouTube video earlier of the dot moving around. Oh, he's going to be implementing temporal memory on an FPGA for embedded AI contest. That's cool. Ding. Feeling excited for me. Also getting too excited. The HTM core I'll be working might not have access to the main DRAM due to some limitations of the embedded platform. I can only hope we can solve it, or it ended up being an issue, unfortunately, due to... Geez, I don't know. This is honestly the optimization stuff. I don't usually spend too much time on because the theory is still so deep. Like there's still so much to parse in the theory. Honestly, Marty, you're gonna feel bad, but I'm not even gonna. I mean, I know what you're doing here, but I don't think I'm gonna read through this. Some of these things. I love that you guys are talking about it, but I don't want to get sucked in to optimization discussions. So I'm going to move on. Oops, let me go back to unread. Implement spatial pooler with connections backend. Bresnak is also named Mark Odehall. He's long-term committer on NuPic and as heavily involved in the current community fork of NuPic. The idea is to ditch separate code for SP and just use the TM. Oh, yeah. Yes, so basically he's saying this is done in the community fork already, which is great. I love what you guys are doing in the community fork. Not oscillations, traveling waves. Hey, Gary's back. I haven't seen Gary in a long time. Gary did some really cool .NET animations in this virtual world with this little icon deal. You should go check out some of the stuff this guy did in his post activity. It's probably, yeah. Look at this stuff. This is amazing. I love this UI. It's just so cool. Anyway, if you look at, there's some videos of the stuff running, and it's just really neat. So yeah, he's really interested in oscillations. A lot of his stuff deals with oscillations. Okay, they're talking about a paper. Oh yeah, because Mark Brown, or BitKing, just posted this Nature paper. And I don't think I've read this. Don't think I've seen. There was recently. Why is this? Why did it pop down all the way? There was recently something that came across my desk, but it wasn't this one. So Gary says he's still confident. I don't want to go through this whole video. Is it only 26 seconds? Ooh, that's cool. That's cool. That's very cool. So these are like directional arrows, and you can see sort of the wave propagation in the brain. This is really interesting. All these circuits. I mean, look at these. They're all circuits, right? That's so cool. I'm so confident HTM theory will work for temporal related learning that must occur at each place in the cortical map. Traveling, yeah. Yeah, so both Gary and Mark Brown, I think, are on a similar page here. They have some other higher level theories, and HTM will hopefully play a role in those theories at perhaps a local level. But they're sort of putting together like the whole, more of the whole brain. How does this region connect to this region? I'm interested in that too, but I can't focus too much about it. Right, Mark is exactly agreeing with them, saying, here's my references. So he's saying it's a suspicion that these oscillations arise in the thalamus and are injected into the cortex in layer 4. That could be. Casey seems to be pretty well informed about neuroscience stuff from what I've read. Some oscillations are sent from higher order thalamus to primary cortex in L2-3, possibly L5A. I don't know if they're relevant. There's so many connections. I like how he does this. If he goes off on a detailed tangent, he puts it in this little thing. Casey knows a lot about like barrel cortex in rats, rat whiskers. This is a great way to study cortical columns is rat whiskers, because each rat whisker seems to have a direct connection to one cortical column in the rat cortex. So you've basically got a unique separated sense. If you think of each whisker as being one sense, like hearing or sight or whatever, if you can think of each whisker being one sense, that leads to one cortical column of cortex. It's a great way to sort of study the cortical column in isolation. So I really like reading about the barrel cortex, and he brings a lot of discussion about that. Rhythmic whisker simulation. There's so many papers I don't have time to read. There are multiple frequencies in the cortex seem to be doing different things, right? That's good. Mark's got theories about hex grid formation. L23 may be working at a higher, like gamma frequency to do local voting on hex grid formation or macro column voting. Yeah, so these different oscillations got to be doing different things. They could have to do with scaling, perhaps. They could have to do with I don't know. There's a lot of things they could be. Gary, thanks for coming back to the forum. It's nice to see you around again. I don't know if you're listening, but excellent. So the paper video show was a problem. So glad that they're sharing papers and excited by the papers. When is the Thousand Brains theory going to be implemented? I was expecting this level to reach for another year or so. Putting together a project where tiny agents learn to structure a map. What is this? Where did this come from? Oh, I haven't gotten here yet. Have I? Okay. So, okay. Then by the end of the summer, the only thing I might only need to add is a moving invisible shock zone arena environment. Plug the creator's rudimentary brain into that. So the Thousand Brains, the one thing I think, and if you look at the 2D object recognition problem that we're working on, I keep waving away the idea of displacement cells because that adds an extra complication, and I don't quite know how it's going to work, because displacement cells allow you to construct objects out of other objects. And yeah, so I want to do that at some point, but I don't know how to do it yet. Mark wonders if there's a path from lower brain structures through the thalamus to the cortex. I've noticed that there are patterns very similar. I assume there are paths from lower brain structures through the thalamus to the cortex. Oh, maybe there's not. Maybe, because I mean, all sensory input goes through the thalamus, I think, except for some. What sense doesn't? There's some sense it does not. I can't remember. Is it olfactory? It's something like that. Oscillation phases of glomeruli. Olfactory bulb. I have to know Sir Penver somewhere. Sniff cycle. Oh. Is this just a time-based thing? What is a sniff cycle? Small pattern end up in the cortex. Ugh. I don't know. Okay. No unread. Oh, a couple of new things. This is 1 day ago, 13 hours ago. Spatial pooler serialization problem too big. I have stored a spatial pooler as follows. Open temp, write to file. I cannot reload it using read from file. Expected total words less than or equal to traversal limit in words messages too large. Increase the limit on the receiving end. C, cap, and P, reader options. Okay. The above error message suggests setting the reader option. I have figured out what needs to be done. Set the option called transversal limit in words, which has a default value of 8 times 10, 24 times 10, 24, but I cannot figure out how to change it. I figured out that cap and P is a C++ program, but I cannot work out how to set this parameter from Python. Cap and P! What is the normal size of a spatial pooler when stored by this method? Mine is 83 megabytes. Yeah, I mean, it depends. It depends on what you did with it. It depends on how big you made it, because the spatial pooler is entirely configurable. So if you make it 1,000,000 cells, it's going to be huge. So how big did you make it? Do I need to make it smaller by reducing the size of my input? No, you need to make it smaller by reducing the number of columns, the number of mini columns, excuse me. Pi cap and P. Okay, let's say, I might be able to help you. Let's see if I can. So I know pi cap and P. Let's see if pi cap and P has a way to, see it doesn't, it's missing it. Transversal, I think the transversal limit in words and nesting limit options are not being passed to flat array. I added the ops argument to the line below. Ops. Okay. Oh, okay, wait. Maybe I just need to look up reader options. So maybe let's, instead of pi cap and P, let's say pi cap and P reader options. Sorry. There we go. No way of setting, hitting transversal limits. Let's try no way of setting. With some very large RPM, and we're hitting the transversal limit. Looks like in order to do the same thing on the pi cap and P side, we just have to pipe a reader options from the two-party client. So this was closed. Let two-party clients and servers take reader options. Okay. So now I need to figure out what happened here. What was changed? This isn't really where I want to be. I need to find out where the API changed. Is there a link to a spec? Maybe there's a spec. I'm not sure. Let's look at this one. Hitting a transversal limit. Reader options. No, this just comes up in an error. But that's the error. Seeded message transversal limit. Wasn't that the same error? No, message is too large. That's not even the same. That's not the same error. Add wrapping of reader options. Thinking what's going to start with this. I'm not sorry. Lazy. I went ahead and wrapped it. So we're going to see commit. This is pi cap and P. Oh. Read helper. Hold on. Unify this. So he added to the helper transversal limit in words, flat array message reader. That was part of what he wrote, wasn't it? I can get rid of this. No. I can't figure out how to change it. Traversal limit. So whatever is emitted here now can have a transversal limit in words. So what's it called? Stream FD message reader. That looks like it's private or protected. So where is the public API? Flat array message reader, schema, packed FD packed. I don't know what PXD is. Schema CPP PXD. I don't know what a PXD file is. But it's letting you. It's now can send options into this flat array message reader, which will allow you to put in traversal limit in words. But how does that help? I mean, how is this exposed in? I do not know. Okay. Oh, maybe I should just read the docs. Reader options. Add reader options. That's it? Well, what's the... Dude. All it was a... API reference. No, it doesn't have any. Is there any reader options? There are no reader options. Okay. Let's go back to the forum. That is an let's just say, unfortunately, I'm not sure that PyCap P even exposes. For anybody who's listening, PyCap and P is a serialization, a really fast, powerful, flexible serialization protocol in C++ that sort of works on top of protocol buffers, or has something to do with protocol buffers. I don't know. Anyway, PyCap and P is the Python, client extension of that, the Python interface for that, so that you can save Python objects in this using this protocol. But I don't think it even exposes reader options. C docs search. Okay. So I'm going to say try fewer mini columns instead of 2048. Try 1024. It may perform just as well. Okay. One more new thing. SDR classifier will not compute. I'm trying to train an SDR classifier, but I can't even first training pattern. Can't get even the first training pattern to compute our message. Wait, what? Bindings, algorithms. So if you're trying to train a classifier, does that mean that you're piecemealing this together? You're using directly algorithms API? I guess that's what I need to see your code. I need to see your code. Will be More able to help if you can share your code. Are you using the algorithms API or something else? And when I show the algorithms API, I really should click on the algorithms API quick start and link it. All right. I think I have caught up. I caught up with the forum. All the posts, all the latest posts are me. Okay. I think that's good. Self-improving intelligence. I haven't read this. Paul is trying to create a low-level organism. Basic components need to control a body, form models of itself, of its world, and learn to satisfy needs. Select breeding. That's interesting. Yeah, I like that idea. It's like an evolutionary sort of thing. The participants are to the judge an algorithm is only concerned with how well it's sort of like swarming. Yeah, something like that would be a good idea. Self-improving intelligence. Trying to wrap my head around the implementations. Lowest level. Oh, this isn't an old form. This is interesting. I don't know if these messages are shown for everyone. Let's find out. I'm going to open up an incognito window. Hey Falco, nice to see you. I'm back on the forum after a week offline at 6th grade outdoor science camp. No. Okay, so that's interesting. Apparently, I get to see that we haven't seen this user in a while. But could you not go down the evolutionary computation route to evolve your agents, so to speak? It would be great. I mean, I like this idea. It'd be great if we could come up with some general intelligence tasks that any intelligent agent could be sort of tested with and evolved using something like this. I like that idea. And this is you, Falco. The internal state of the system. I'm not sure what exactly he was talking about the same thing either. Yeah, the application would be the dog. The dog show would be like the evolutionary, the environment the applications are evolving within. Internal states wouldn't matter. Okay, good. Paul cleared up. Paul's good at clearing things up. This is also me just like catching up with the conversation too. Creatures being judged to be able to place value on their own internal models based on how well they are meeting their needs. Yes, this of course requires them to know their own internal state. This internal valuation should self-assemble without requiring a third party to view the creature's active neurons and interpret them. I agree. The judge is a third party which only needs to generate composite intelligence scores based on the results of various tasks. Purely objective function, doesn't require knowledge of internal states. Yeah. Yep. Good answer. I could give Paul a good answer for every one of his posts, but I won't. I'll judge everyone with a different ruler. Jimmy. Yeah, labeling happens via some pooling algorithm. Generated prediction. So cool. You didn't mean to coax you in a long conversation. Yeah, right. Yes, like a baby, starting random, gradually becoming purposeful. This is how AGI will be created. Like a baby, starting with random movements and gradually becoming purposeful. I believe that wholeheartedly. We are going to create a structure for intelligence to emerge. It will explore space through initially random movements as it's building up a model of space and a model of itself and via its interactions with space. And at some point, it will have learned a model well enough that it can navigate. Now, I do not know about goals, rewards, punishments. I don't think too much about that yet. I'm still only thinking about the object modeling portion of it with the, and how motion is required for that and how space is modeled through motion. So much, yeah. There's so many things to talk about on the forum. Whew, it's hard to keep up with. Everybody's interested in this idea. It's because it's a good idea, Paul. Sorry about the background noise. My kids are upstairs bouncing off the walls, apparently. Okay, go. Distributed. Good. So I have to compare this to swarming and apply lessons learned from swarming. I don't think it should matter what language it's in. It should be language agnostic, intelligence agnostic. It should just be a way to judge a system, an agent, or something to perform some general intelligence tasks. Distributed would be awesome. Interface provides API new challenges. Motor commands. Communication from sensory input to the creature and from the creature to motor commands will all pass this interface. Yeah, that makes sense. So you're basically creating an environment, an interface for an environment that will be a test bed. And it will decide how well different agents in that environment accomplish whatever goals are set before them. Right, new challenges could be added. Yep, I like this idea. I think, I still think, and I think Jeff thinks this too, that robotics is going to be probably one of the first major applications of HTM. And that's all going to start in simulated environments like we're all talking about right now. This could be a toy simulated environment of however many dimensions you decide it will be. I'm working on two-dimensional environments. The thing about working in 2 dimensions is I'm pretty sure that scaling to higher dimensions is not going to be a huge deal. Now, orientation is going to be a big deal, but but I don't think adding a third. I think once you go 2-dimension, that's many. You're in many dimensions now. You just add another dimension to the arrays. You know what I mean? The interface is a critical component. There's obviously he's put a lot of thought into this. Frames of Mind, a Theory of Multiple Intelligences. Howard Gardner. Interesting. I have not read that. I'm going to bookmark that. And star it. Thanks, Paul. That's good stuff. It seems... Oh, let's read about cell death. Okay, cell death. I didn't read this before I left. I don't understand much about what is cell death in the brain. And how the spatial pooler can implement a cell death. Well, we currently don't. As I understand, if all connections in the receptive field of a column are connected, it means that this column is dead. No. That's not what that means. If all connections in the receptive field of and we're talking mini columns here, receptive field of a mini column, if they're all connected, this means that the column is death. I don't think so. Jimmy already answered this. Death of neurons due to Parkinson's, Alzheimer's, death by overconnection. I see some simulation about cell death. I don't understand this concept. What is... we don't have a simulation of cell death. Oh, yeah, so I know what you're talking about. So one of the spatial pooler papers, okay, right. one of the spatial pooler papers showed tolerance to simulated cell death. I think this is what Verdi is referring to. We did not implement it, how do I say this? It is not a part of the SP. Let's call this spatial pooling process. It is just something that SP handles well. Yeah, cells die all the time. Sometimes it's random. Spatial pooler simulates some cells. All good models of the brain should be able to survive. Yes, that's exactly it, DMAC. There's some discussion of the general SP operation and the part of the paper regarding failures on this thread. Okay, so it's relative, related. Yeah, that's definitely not true. Okay. Okay, that's what I'll leave it at that. Okay, what's going on here to it? I'm still live, that's good. 3 viewers. Hello viewers. Does anybody have any questions or want to guide me in some direction? I'm just going through more forum messages that I haven't read. This is Mac again. I think I already answered one of his questions. Gosh, I wish Nupic worked better on Windows. So Nupic and Captain P does not work on Windows. Nupic with Captain P does not work on Windows. I'm just going to have to... Yeah, there it is. Captain P just does not work very well under Windows. That's right. Thank you, David. I'm going to give you a badge for that. Good answer. Actually, I should read the answer first. Oh, he's suggesting to try the community version. Alright, so you're going to be a community helper. Thank you, David. I'm so glad that this is happening. Once we get Nupic 2.0, if and when that happens, we'll not have Captain P. Okay. That's good questions. So that's the intention, yeah. There might be, I can't tell because I'm not keeping track of the community code, but hopefully it'll be real close. Community version, there are warnings not to finish transfer code. Copying, bring it just this way. Yes, thank you. There is no way that Windows can load the Python extension libraries built for Python 2.7. This is a problem with Microsoft Visual, whatever, compiler, the C compiler compatibility with old Python Live. Captain P is Captain Proto. It's short for Captain Proto, and it's because it's built on top of protocol buffers, and it's a way to serialize any object in any language at any time, so you can send it over the wire, and something else on the other side can deserialize it and use it. And it's very flexible, but it's this huge pain in the butt. It has been so hard to deal with, and I don't want to use it anymore, and we're going to pull it out. I don't think we ever should have put it in, but that's another story. Okay, I am going to move this. At this point, I'm going to split this topic, I think. I'm going to split this topic. Because this should be in the community fork, I think. Let's split it right here. Let's select this one and below. And we'll split this off into the community fork. Move to new topic. What do we say? Running community fork on Windows. If this isn't a good enough, no, yeah, you can use the serialized version, the serialized things that Captain P creates in any way you want. I mean, we just write them to disk and unwrite them to disk. You can put them in a stream. You can use them in web services. You can, whatever you want. This is going to go in the fork. I'm not going to put serialization. I don't know what optional tag, but I'm going to move that. Okay. What other topics? Running community fork on Windows. That's what I just created. Regarding multi-step prediction and anomaly detection. Hi, everyone. When you guys say the model will make multi-step predictions, what does it actually mean? Will the model make predictions next second or next minute? So if I'm doing a time series analysis, does the next step prediction depend on the way I input my data? Okay, so Paul's explaining this. The multi-step prediction is a trick of the classifier. HTM makes predictions. So your brain is constantly making predictions. But it's based on sort of the time frame or the time context of time in which you observe the world. So you're making predictions about what's coming next, immediately next. You can also think ahead and use your imagination to imagine what you're going to be doing tomorrow and predict what's going to happen tomorrow. That's not the type of prediction that we're talking about right now at this low level. The low level type of temporal predictions that are being made in response to sensory input is basically, what am I going to feel as I move through space? Those are the types of predictions that we're talking about. What are we going to observe as we're moving through space? That's what HTM is doing. So your brain's not necessarily predicting, what am I going to predict 1 time step next or 100 time steps next when I'm over here? That's not what we're really, those aren't the types of predictions that we're doing. When we do a multi-step prediction, it's really something that the classifier is performing. It's saying, okay, based on this cell state, and you tell the classifier you want to learn 1 step ahead. It'll keep track of all the last predictions and how well it did, and it will go back and decode that into the language of the encoding space and tell you the probabilities of what's coming next. And when you do a multi-step, it basically does that exact same thing, except it doesn't look 1 step back, it looks X steps back. So it's not a trick necessarily of HTM that's giving you the multi-step prediction ability. It's how the classifier is set up. So yes, Falco says if you get an input every 10 ticks, you'll get a prediction in 10 tick intervals, exactly. But if you get an input, well, see that's as long as you're not inputting, empty information, tick 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 tick, and every 10th you get something. It's if you decide to predict 1 tick ahead, for example, that's different from 10 ticks ahead. The hard thing to realize is your brain is not time stamping every moment that comes into it. It experiences time relatively based on a lot of internal conditions, chemical balances in your brain or whatever. When you have a lot of adrenaline running, time seems to slow down. So time is a bit warped in your brain. Time doesn't mean as much. It's not as solid and stable in your brain as it is, I think, in reality, or how we perceive it in reality. Um, oh yeah, if you have a regular like spike every X ticks in an otherwise noisy stream, yeah. So if you get a spike every 10, it'll predict that. If you're one step away from that spike, it'll predict it. If you're 2 steps away from that spike, it won't predict it because that's not coming next. It's not coming next. However, if you have a 2-step prediction, a multi-step prediction, you say don't predict what's coming next, predict what you think is coming 2 steps. It's just you're telling the classifier to keep track of the last 2 steps and to do a reverse classification of it. It's not as, I think Paul's probably explained just fine. My stream produces the same timestamp for 2 different value for 2 seconds. My stream produces the same timestamp for 2 different values for 2 seconds. That doesn't make any sense. That doesn't make any sense. Yeah, sample data. Give us the sample data. What do you mean, how do you set that prediction request? The multi-step? It's a parameter in the model params for temporal memory. I think it's steps ahead. It's something like prediction steps ahead. It's something like that. I don't know what that is. Something's notifying me. Somebody else is live on Twitch. I've been like perusing Twitch lately, so I like signed up to watch a whole bunch of people's streams. Okay, stupid specific questions about coding HTM. I think, oh great. All right, someone's trying to write an HTM in C++. Cool. Are you new? Hasos? It's been around a little bit. Join March 1. Not too much. Okay. I just like to see how much people have been reading. How does the brain do it? How do you set that prediction request? I don't know how the brain does it. It's a good question. I don't know. But when you start talking about predictions in 5 minutes, it's not the same type of prediction. It's not a sensory motor prediction. You're imagining. You're like bringing in the whole. It's not just your immediate state of things. It's the state of things outside your immediate sensory input. Like when you think about what's going to happen in 5 minutes, you have to think about things that you're not immediately observing. You know what I mean? It's not the same type of prediction. I don't know, and I really don't know how it works. I mean, AGI is not right around the corner. Okay, so about the pseudocode. Segments for column, right. Given a set of, I hope Brev has answered this. Given a set of segments, return the segments that are, Brev is working on his own implementation. Brev used to work for Memento. He did all of our web stuff for a long time. He's a great engineer. And it looks like he is letting them know. Right. When it says on a cell, like the synapse coming from the cell, spreading a synapse elsewhere or synapse. Axon out. Dendrite segments on cell and column synapses in. Not sure I quite understand that graphic. In a set of segments. Okay, so we're talking about distal dendritic segments on a mini column. This function should, if I were writing this function, I would call it distal segments for mini columns. Given a set of segments, return the segments that are on a cell in this column. When it says on a cell, it's coming from the cell. So the tricky thing here is segments, we don't, in a real neuron, it's like dendritic segments fork and fork and fork and fork and fork, and they create this great big tree. So outside of the proximal sort of bubble around the soma of a cell, all the distal segments, we're treating as just like a list of segments. We're not treeing them together in any way, but we're saying that each one of these segments could potentially create a dendritic spike, an NMDA spike, that will cause the soma to become depolarized and go into a predictive state. All of these distal segments we're just putting into a big array. We're not saying, oh, some are close and some are further away and some are over here and some are over there. It's all like sort of random, and they're just in a big array. So on this cell just means somehow attached to the cell. It's not coming, and we're simulating that the mini columns are basically, we're sort of simulating that they're just one neuron. You know, we're saying they're all going to share the same input, but that's for proximal input, not distal. So yeah, so the distal stuff will spread. Each segments for column. So that may be proximal segments for column. Now that I think about it, I'd have to go look at the code. Let me just see where this conversation went before I go spend a bunch of time on it. It helps a lot. Okay. Okay. I'm just going to see if this guy is making progress or not. Yeah. With multiple cortical columns to form a hierarchy. Ugh. Okay. I don't know if this is a newbie conversation. I think I might move this. I'm getting quite theoretical here, but I'm going to let it go until the OP comes back with a more detailed question, because I'm not sure where exactly he's going with this. But this isn't a newbie question. This is going to be in hackers. All right. What's going on here? Still a couple viewers. Thanks for watching. I know Falco's probably still there. Who else is online? I'd love to hear you pipe up and let me know what you're working on. If you're coming from Twitch or from someone else from the forum. Oh man, this is a detailed. This is really detailed. I love that Casey does this, but I honestly cannot keep up with it. I am just not good enough of a neuroscience. So if you want, this is so packed with info. Like I said, Casey has a lot of knowledge about barrel cortex and rats, and so a lot of this I think is informed by that, but it's really a great place to study cortical columns. So I imagine all of this stuff is really useful. But wow, that's a lot of notes. He's been working on this for a while. And he gets links to his sources. Yeah, so the functional properties of barrel cortex neurons. And then look at all these references. Man, Casey, you're really on point here. Yeah. Yeah, Mark says, I see I have several evenings of review in the near future. Absolutely. It's insane. This is, I've given Casey so many of these awesome badges, but I'm going to keep doing it. Because it's, when you can put something like this together, I haven't even read this, but I can tell that he has put his thoughts together in a way that is trying to communicate. Like it's this type of stuff that's that can help you with further theory. Like if someone summarizes a bunch of papers and says this is connected to that and this leads to that and this leads to that, it's super helpful. And I don't usually. I'll let the research guys read this as they want to, because I think most of them see the neuroscience stuff. But most of them, whenever I bring this stuff up, they usually are like, "Yeah, I know." They have a pretty good idea of the connections. It is, yeah, it's super daunting. And like I said, you saw me skim it. I didn't I didn't do a quick read. And look at all these papers. Geez, Casey, it's crazy. But I mean, this is a huge really awesome resource. And yet another functional imaging of visual cortical layers and subplate in awake mice with optimized 3-photon microscopy. So subplate remnant cells can probably modulate higher order thalamus from primary cortex. Higher order thalamus. Oh, we're talking hierarchy. Yeah, we're getting really good at monitoring neurons. I think we're going to discover a lot about the hierarchy soon enough. The thalamic projection is usually thought of as feedback down the cortical hierarchy. L6, cortical thalamic projections from cortex to thalamus, coming out of L6, are usually thought of as feedback down the cortical hierarchy cells. It is daunting. Predictive brain. I'm going to skip this one. Oh yeah, well, if you look at the thalamus and how it projects to cortex, it's like a little, like if you look at the map of the areas of thalamus and what areas of neocortex it projects to, it's like a mini neocortex. Like the visual areas here and the cortex of visual areas here, and they have, like I've got a, here. This is my, I colored in all this stuff. There's a big section on the thalamus in here that I was trying to study. Here we go. That's the thalamus, and it's got all these projections. Where is it? Here we go. So here's, I don't know if you can see this or not. Check this out. I think I can. There we go. There it is. The thalamus, and it projects up. Where's the right? Here's the right picture. But this thalamus is all broken up into pieces here, and each piece projects to a different part of neocortex here, and they match. Like this one goes to the same side and in the same location. So the little football is like a sort of a mini version of half of your neocortex, and the projections project right into the same area of the neocortex, down, up, and down. So, you know, we think that all the thalamus researchers like to call the thalamus a blackboard. They call it, you know, they use the metaphor blackboard, but you have to think of it as like a really, really fast blackboard. It's like, I think it's like projecting what you think is going to happen and then overlaying what actually happens and then erasing it and like doing extremely quickly in a way that you can compare immediate sensory input with predicted sensory input and respond somehow. I don't know how it works, but they call it a blackboard. It's not something that I'm not sure that it has a huge learning capacity. That's other parts of your brain are learning, but it is like the place where where reality sort of plays out. It's the first place sensory input hits, and I think that's where you perceive reality is in the thalamus. But like I said, I'm not even actually a neuroscientist. SDR classifier in JavaScript. Okay, Jimmy. Looks like Paul's already taken this one. I have not written an SDR classifier in JavaScript either. So, what's the biggest concern with maybe I honestly don't even know how registers really even work. But if it's the difference between RAM and disk, potentially that might be some way to do it. I don't even think RAM makes sense, because you can keep a ton of memory in RAM and leave it there for a long time, and I don't think that's happening in the thalamus. I think it's like an instant sort of like the now, like what you perceive as now, the present, is happening in the thalamus. And I think that it's constantly rewriting, it's constantly comparing sensory input to predictions there. With point neural networks, you get an input mapping to some output. There is no good one-shot learning, and the system generally has to learn offline, right? With HTM, you get input mapping to nothing changed or something happened. Get an input mapping. That's why I think that the hex grid coding is such a big deal. With hex grid coding, you get input mapping to some stable hex grid pattern, and all the other advantages that HTM offers for fast online training and sequence learning. With HTM, you get input mapping to nothing changed or something happened. I don't understand that. Do you feel the same way once you think about incorporating motion and the role HTM plays in sensory motor? Did I put my face back? Yeah, okay. I'm just checking. Let's see. Okay, thank you, Paul, for splitting that topic. Okay, good job. I think I'll ask this. What do you mean by this? What do you mean? What do you mean? What do I when HTM gets an input and it creates a prediction of what it thinks is going to happen. But he's trying to. I'm trying to talk about neural networks. Neural networks, you get an input to some output. So like you get some input and it's like classifies it to some output. But with HTM, you get an input, and yeah, there is no classification. I don't get it. It's not nothing happened or something changed. I guess I just don't understand what do you mean by this? I'll leave it at that. Yeah, it seems like neural networks, mostly what they do is classify. Now there's generative neural networks that do more than that, but I don't know enough about generative. I don't know enough about GANs to talk about them at all, so I probably shouldn't say anything. That's something that I need to look into. But all the examples I see, all the powerful things, especially pattern recognition, spatial pattern recognition, seems to be some type of classification, and sometimes it's just a classification of what feature exists in the set. You can sort of think of. I'm talking out of my. Yeah. Okay, crashing on serialization SP model to file spatial pooler proto error. This is Mac. I think you're on Windows, and that's the problem. I think this is the same person who's running. The problem is that Captain P serialization does not work on Windows. hopefully, okay, NAB, codependent metrics from a single system. All right. Does any of the NAB datasets provide different metrics from the same physical system that would therefore provide different views into the same behavior? No. For example, well, there may be, some of the datasets might internally, but yeah, I don't think so. I don't think so. Well, I'm just going to answer that question. I don't think so. Non-redundant contributions of Mar's 3 level of analysis for explaining information processing mechanisms. I've read a little bit of Mar. Favorite hobby horse. It's another paper. Okay. Yeah, I'm not going to read this. Ignore swarming. Because I have 2 issues here. Once I swarm over and set prediction field A, the next time I want a prediction of B, why should not I want a prediction order of B? It makes me hurt. Takes much time, which sometimes makes me hurt. Yeah, it's awful. What do you want your application to do? If you just want what kind of input data do you have available? An answer I can help out if you need to swarm or if you can use some standard starting model params and what's the word? Commute and test from there. Okay. Why? There should be like, I thought I had, never mind. I'm just talking to myself. Question about sparsity and local inhibition. There's a lot of messages on this forum while it's gone, which is a good thing. I also have a problem with sparsity and local inhibition. Because I've read the code, oh, I think I saw this. Who flagged this for moderation? Okay. Oh, okay. That was just to make it its own thread. Good job. You can't strictly control the global sparsity with new, you need an alternative approach such as this. Very good. Yes, we talked about this, I'm pretty sure. Okay. Thank you. Community is monitoring itself. Max started a lot of topics while I was gone. How can I know that the performance of SP was improved during the learning process? If you send in similar input to the SP, it should produce similar output. The more different the input is, the more different the output should be. Start with that. Oops, what is that? Okay. Why is this still not marked as red? Oh. Okay, that's fine. Oh my gosh, I think I made it through them all. I made it through them all. Okay, cool. How long did that take me? That took me... I have no idea. What's my stream uptime? 1 hour and 35 minutes. Alright, so it took me 1 hour and 35 minutes to get through all of the HTM Forum topics, or all or discussions that happened while I was gone at 6th grade science camp. There we are. Okay, I am going to log out. Thanks for watching, if you were watching. Tune in on Monday. I'm going to have a live stream Monday at 1 p.m. Check my channel. It'll be about, I'm going to chat, so hopefully interactive, about artificial intelligence just in general. I'm going to talk about weak AI, strong AI, deep learning, classic AI, biologically inspired AI, a bunch of stuff. And I'd be more than happy to take questions. I hope people join in and see me then. So I will be back in my main office Monday, 1 p.m. Pacific time. That's UTC -8. So hope to see you there. Thanks for joining. Thank you, Falco, for always being there. See you on the forums.